So today what we're going to be talking about is volume of 3D shapes. Polyhedra is the math name for that. So we're going to talk about volume. Some of these volume formulas you should know already. It should be a review. We are going to get into some of the more obscure 3D shapes that you might not know the formulas for. So hopefully a lot of this will be review and some of it will be new. So polyhedra, let's remember what the shapes are that we're talking about. So we're talking about prisms. We're talking about cylinders. I do want to point out that prisms and cylinders are the same shapes. We only make the distinction because cylinders have circles and they're round, so they don't actually have edges and vertices. They don't have points. But as far as our formulas are concerned, prisms and cylinders go into the same family because we're talking about shapes that have two shapes at either end that are the same size, and then you're just connecting them, with these lines. So with a cylinder, it's two circles on either end. With prisms, it might be two triangles on either end. That would be a triangular prism. Or it could be a trapezoid at each end, and that would be a trapezoidal prism. It's just got to be two of the same shape on either side, and then you just connect all their corners, and that's what makes it a prism. So those kind of fall into the same family just because there are two shapes on either end that are connected. There's only a distinction made because of cylinders having circles. The next one would be pyramids and cones, which also fall into the same family. The idea with pyramids and cones is that we have one shape that's on the bottom, and then we take all the corners and connect them up to one point. So when I do that with, a shape like a rectangle or a square, I just take lines from all four corners and they go up to one point. So that's a bunch of triangles around the edges. A circle doesn't have corners, but we still can take, all the way around, and that gives us that cone shape. But they do fall into the same family again because it's a one shape on the bottom, take all the edges and go up to one point up at the top. So cones and pyramids do fall. Again, just like with the prisms, pyramids are named by their base. So it can be a rectangular pyramid, a triangular pyramid, a trapezoidal pyramid, hexagonal pyramid. So the name of the shape at the bottom / pyramid, that's how we name those. We also have the fully round shape, spheres, the 3D circle. No corners, no edges, everything's round, nice big ball. And then we are going to talk about a couple of other polyhedra here at the end, some special ones that you may run into. As we get into volume formulas, we need to take a moment and go back and review some area formulas. And you may be like, well, Ms. Parker, we're doing volume. Why do I need to know the area formulas? That is a fantastic question. The answer to that question is that the volume formulas require you to have the area of the bases. And so we talked about, I can have a square pyramid or a trapezoid pyramid, but in order for me to find the volume of it, I have to be able to find the area of that square or that trapezoid. So do make sure that you go back and refresh your memory on all of your area formulas. Don't forget base and height and length and width and side squared. Don't forget a trapezoid has two bases, the two parallel sides. And then regular. Let's talk about regular for a second. This is regular polygon. Regular is not just a random word that got thrown in there for no good reason. It does actually have a definition in math when we talk about regular. Regular means that all the sides and angles are equal. So all sides are equal or congruent to each other, and all angles are equal to each other. So it's not just a random polygon. It's regular polygon means that it's a polygon where all the sides are equal and all the angles are equal. A square is a regular four-sided polygon. So that's the definition. So what does the A and P stand for in the regular polygon? So you want to make sure that you know that A is the apophthegm. That is a really interesting word, apophthegm. All right. The apothem in a regular pyramid, kinda, if you want to make a relationship to it, it's almost kinda like radius, but that is a little different. For example, if I have a regular pentagon, so pentagons have 5 sides, and if it's regular, it's got 5 equal sides, so all 5 sides are equal, and all 5 angles are equal. The apothem goes from the point in the center of that shape. So because all the angles are equal and all the sides are equal, there is a point that is dead center to that shape. It would be exactly, halfway between here and here and here and here. It's it's the dead center of the shape. And when we take a perpendicular distance, the shortest distance between that center and any one of the sides, so a perpendicular distance, it does have to be a 90-degree angle. It can be to any one of the 5 sides, but it goes from that center out to one of the sides. That is the apothem. So it's almost kind of like the radius of the polygon, although it's not the radius, because radius technically would be from that center to one of the corners. But the apothem is perpendicular to the sides. So you definitely have to know what the apothem is. P is the perimeter of the regular polygon. So that, if you remember, perimeter is just adding up all of the sides. So if you knew what one of the sides was, and then you know how many sides there are, since it's regular, we can just figure out what the perimeter is. So just a couple of little area reminders, things that you need to make sure that you know, because that's going to help us do the rest of these problems. So next up, let's look at volume of prisms and cylinders. So the volume of a prism or cylinder is to take the area of the base, big B here is the area of the base, and multiply it times the height. Now by height, what we mean is the distance between the two bases. So if I have a square pyramid or a square prism, I have 2 squares on either end, and then these are connected. All right, so this is my square prism. The area of the base, when we talk about the bases, are the 2 sides that are, equal and across from each other, the 2 trapezoids, the 2 triangles, the 2 rectangles, or the 2 squares. These would be my bases. So I have to know the area of the bases. So that would give me that big B. Again, that's why we have to know what our area formulas are. I have to be able to find the area of a square or the area of a trapezoid. So this is the area of the base. When we talk about the height, that doesn't necessarily mean up and down. Height is the distance between those 2 bases. So, if my base is a triangle, that triangle is going to have a height associated with it in order for me to find the area of that triangle. But that's not the height that we're talking about in this formula. This height has to be the distance between the 2 bases in the prism. So let's look at an example problem. Right, we want to find the volume of this particular prism. So first, let's talk about what type of prism it is. It is a trapezoidal prism. All right, so it looks like the base of it, remember, base doesn't just mean the bottom. It's not that the bottom of this. The base is going to be the shape that I have 2 of. So the trapezoid here is actually the base. I've got a trapezoid in the front, I've got a trapezoid in the back, and then I've connected them all. All the corners have been connected to each other. So this is the base, and so this is what I have to find the area of. So first I'm going to work on finding the area of the base, the capital B. All right, so capital B, and this is a trapezoid. So if you go back to your area formulas over there, you realize that trapezoid is 1/2 times the height of the trapezoid times base 1 plus base 2. So that gives us the area of the trapezoid. So first I got to fill everything in. So 1/2, now the height of the trapezoid was 4 centimeters. And base 1, the top base, was 8. And the bottom base was 14. So 1/2 of 4 is 2. And 8 plus 14 is 22. And 2 times 22 is 44. Now that is area, so this is in centimeters squared. All right. So that gives me my big B. Now, for the formula, my little h is the distance between the trapezoids. That's what this distance is. It's, there's the trapezoid back here. It's hanging out, back here, and then these have been connected. So this is the distance between the two bases, so it's going to be 10. So when I take the area of the base, which is 44, big B, times h, which in this case is 10, looks like our volume is going to be 440 centimeters cubed. Volume is always cubed. Don't forget that. So that is how we use those area formulas. Volume for a pyramid and a cone. So pyramids, cones, they use the same formula. Prisms, cylinders, they use the same formula. There's no difference. You just have to find the area of the base. It doesn't matter whether the base is a circle or a triangle or a trapezoid or rectangle. It's going to be the same formula. Volume for pyramid and cone is actually very similar. We're still going to do the area of the base times the height, but we're only going to take a third of it. So it's not giving us that full cube shape. We're only getting a piece of that cube. Another thing to point out is that h in this case has to be the vertical height of the pyramid. Pyramids do have two heights that are associated with them. If I have a rectangular pyramid, there we go. If I have a rectangular pyramid, we have the vertical height, which goes from this point down and is perpendicular to the base. So that is the height that we're talking about. There's also what is called a slanted height. Like if you started at the top of the pyramid and slid down the outside of it, usually we use an L for that, but that is the slanted height. And we use that for surface area, but we don't use that for volume. So you want to distinguish between the two different types of heights. For volume, it has to be a vertical height. So make sure that you have a vertical height when you're doing volume problems. So let's look at an example. So we want to find the volume of this pyramid. So if we remember, volume of a pyramid is 1/3 the area of the base times the height. So we've got some information to find. If I find the area of the base, well, first I have to figure out what shape the base is. The base is the bottom of the pyramid, so that's going to be this rectangle here. This is a rectangular pyramid, so we are looking for the area of this rectangle. And so if you recall, rectangles are length times width, and we have a length of 10 and a width of 8, so the area of our base is going to be 80 inches squared. So that is the area of our base. Now our height has to be the vertical height, so not sliding down the side of the pyramid, but going straight from the top down to the bottom perpendicular. And it looks like our height is 6 inches. So if I take 6 inches and I multiply it times the area of the base, so I've got 80 times 6 is going to give me 480, and then don't forget your units of measure, inches cubed. So area of the base times the height. That's what we're looking for. With a sphere, pretty straightforward little formula. Spheres only have one dimension. That's super easy. We don't have lengths and widths and heights, and a sphere just has a radius. So when you only have one dimension to keep up with, that makes for a fairly easy formula. It is 4/3 times pi times r cubed. And of course it's cubed because volume is always cubed. And since we only have the one dimension, it's getting multiplied by itself 3 times. So 4/3 pi r cubed is going to give you the volume of a sphere. If we look at an example problem, so I'm like, oh, it's a sphere. So this is a plug and chug situation, 4/3 pi r cubed. The only thing I do need to be careful with is to make sure it is actually the radius. Radius goes from the center out to the sphere. They've given me here a diameter. This is going all the way across. So that's not a radius. Don't forget, radius is half of the diameter though. So if the diameter is 18, my radius must be 9. So when I actually go in to plug it into 4/3 pi r cubed, that means I'm going to put in 9 cubed. And so then I can type into my calculator 4/3, 4 divided by 3. Use the pi button. If it asks you to estimate, don't just use 3.14. We can leave it as an exact answer though, because we know that that's more precise. So if I just do 4/3 times 9 to the third, I'm going to get 972. So 972 pi, but I still need a unit of measure. This was meters, and it's volume, so it'll be meters cubed. If I was giving an approximate answer, then it would be 3,053.63 meters cubed. So that is the formula for spheres. Let's take a moment and talk about some of the other polyhedra. Just like we have polygons, and they have names for how many sides they have, the 3D shapes do have some special names depending on how many sides they have. So a shape that has only 4 sides, and we're going to be talking about regular polyhedra here. So one's, again, regular has a very specific meaning. That means that all the edges are the same length and all of the angles are the same size. For a 4-sided polyhedra, it's called a tetrahedron. It has 4 sides. The tetrahedron, if you notice, though, is already a shape that we've talked about. It's just a pyramid. So if it's just a pyramid, then we can do our pyramid formula for it. You can do the area of the triangle that's down here at the base, and then find the height of the pyramid, and it will be 1/3 the area of the base times the height. So we don't have to have a special formula for that one. A side that has 8 equal sides, so 1, 2, 3, 4 on the top, and 1, 2, 3, 4 on the bottom, it's called an octahedron. But notice it's actually just 2 pyramids. I've got a pyramid up here on the top, and I've got a pyramid down here on the bottom, and so I don't actually need a special formula for it either. We have a pyramid formula, so I can find the volume of this pyramid and the volume of this pyramid, and since it's regular, actually it's the same for both of them, and then I can just add them together to get what the total volume for this shape is. So I don't need special formulas for these. I can still find the volume. Another shape has 12 sides. It's called a dodecahedron. And the regular one is made up of pentagons. So we get a regular dodecahedron with 12 sides. It actually needs formula. Okay, it's not made up of a special little pyramid, or this one, you know, is a pyramid. We could get away with using our pyramid formulas to figure it out. It does actually need its own formula, and it is quite an interesting little formula. So it is, let's see if I can get it to show up. Here we go. So see this? There was definitely some quadratics involved in this, you can see, but 15 plus 7 on the square root of 5, all divided by 4, times a to the 3rd power. Now in this case, a is not standing for apothem. I do want to clarify that. In this particular problem, a is actually the length of one of these edges. It is regular, so all of these edges are the same length. So one of these edges here is the a that it is referring to in the formula. And so those are our volume formulas for our regular polyhedra.